Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, and faculty members across India, initiated by myself in 2017. And we used to organize online problem solving sessions and online test series to help the students who prepare for national level competitive examinations in higher mathematics. As a part of that series, today we have a session on numerical answer type questions for JAM examination. Today we have Dr. Asif Navas Kia with us to discuss problems from numerical answer type questions of JAM examination. Dr. Asif currently working as an assistant professor at TKM College of Engineering, Kollam, Kerala. Dr. Asif did his M.Sc from Hyderabad Central University and he qualified CSIR NET with JRF 4 times and he did his PhD from Kannur University. I would like to thank Dr. Asif for accepting our invitation and joining with us. I'm sure that today's session will be really helpful to everyone. I welcome everyone to this program. Welcome, Asif.
Okay, thank you, sir. So I think let us start this session because we have only 1.5 hours, and we will try to solve more problems, and especially I will tell you how to prepare or how to write examination while there are only 10 days left. So in the examination hall, it's the crucial part of any competitive examination. While you are seeing a questions, how to approach to a question is very important. So that makes the difference. Even if you know you are prepared very well for the examination, but the 3 hours in the examination hall is crucial. So you should focus on that, and I will tell you how to write answers and how to select the question, and also how to identify the clues from the question to solve the question. That is very important in case of competitive level examination. And one of the key factor is time management. So today we will focus on numerical type questions for JAM 2024, and especially I will do numerical type questions in the previous year questions, 2020. Three numerical type questions, and moreover we will get answers from various sources, but the important thing is while answering a question, it's very important to identify the clues available in the question. So I will more focus on that, and we solve the problems. And one of the important key factor is time management in the examination. So I will tell you how to answer the problems very quickly. So this is our aim to crack examination, and this is a strategy for JAM examination. I think we are on the stage of 300 exam rehearsal. That is very important in the more helpful. And in the examination hall, it's very important to read the instruction carefully. Okay, So before attempting the question paper, that is usual procedure. And one of the important thing is be cool. Be cool in the examination hall. Don't take if you are in stress mode, or it will affect your answering capacity. And also be cool and relax on the examination hall. And before going to the examination, you can use some breathing exercise, meditation, etc. So that will be very helpful. And one of the important thing is we are writing JAM examination, and the JAM is the entrance examination for the prestigious IITs. That means if you qualify that, you will be in the one of the top institute in the country. So you should be aware of that. Every question must be the question that will be very tricky, because the question paper setter will set the question in such a way that the one of the intelligent student should solve that. So each and every question you should think about the perspective of the question paper setter. That's very important. So not jump into the answer. You just watch the question or see the question, and you can identify any clue in this question. So, and another thing is, every question must have an hidden clue to solve that problem. Or so if we will change something, you can easily solve that problem. And one of the important thing is, most of the problem we can do it in 3 minutes, and few about 20% of question it will take time. Okay, so now okay, so now let us move into numerical type questions 2023. And the first question I'm going to the question is the global minimum value of f of x equal to mod x minus 1 plus mod x minus 2 all square on real is equal to. And this is one of the easiest question in this question paper, and it may take consuming, because it is two mark question, right? 2 mark questions. And one of the important thing is, here f of x is given as mod x minus 1 plus mod x minus 2 all square. So the thing is mod x minus 2 all square, this is a tricky one, because the most of the students get confused here. Actually, mod x minus 2 all square is same as x minus 2 all square. So there is no relevance in that, but in the question, it might be confusing. So this can be written as, actually, mod x, f of x can be written actually mod x minus 1 plus x minus 2 all square. So now the problem only comes when x is when x greater than 1 and x less than or equal to 1. So the f of x will be changes, the value changes when x greater than 1. We have mod x minus 1 equal to x minus 1, and mod x minus 1 equal to minus x plus 1 when x less than or equal to 1. So this is the thing. So now what we can do is, so what is the thing? You should identify this thing. This is don't get confused here, and this is a factor of then we will use time here. Okay, so this can be written as x minus 2 all square. So you should identify it at the time of first read. Otherwise, it will take time. And we know that extremum values occurs at a critical point, and we will write what is critical point. Critical point is the point at which f dash of x equal to 0. That means derivative at that point is 0, and we know that extremum, minima or maxima will occur at the critical point. And also we know that the maximum value of this must be infinity. That means it's a function, positive function. As x goes to infinity, it will be infinity because there is no global maxima there. Okay, so if we get a minima, that may be local minima or global minima. So now we can write this f of x as f of x equal to x minus 1 plus x minus 2 all square when x greater than or equal to 1, and also f of x equal to minus x plus 1 plus x minus 2 all square for x less than 1. So now we will find the critical point for both. Okay, so what is f dash so in order to find the critical point, f dash of x equal to 0, then if we find the derivative of x is 1, x minus 2 all square is 2 into x minus 2 and equal to 0. Now if we substitute this, we will get x equal to 3 by 2 and y equal to 3 by 4. So the value we got, the critical point is 3 by 2, and the value at that point, that means f of 3 by 2 equal to 3 by 4. Okay, so now we will check whether what will happen on the second case. So when f dash of x equal to 0, in the second case, you will get x equal to 5 by 2. That means critical point is 5 by 2. But the thing is, we took this when x less than 1. So this is not possible. Okay. So the only possibility is x equal to 3 by 2 and the critical value is, so what is the global minima value is 3 by 4, that is 0.75. So one of the important things is you will get the answers here. So one of the important thing is you should what are the time losing components in this question. So this one is a time losing because if we are get confused here, it will lose our time. And if we are we know that we can rewrite it in the first point of time, mod x minus 1 plus this, then it will be very easy. And also we know that extremum occurs at the critical point, and this doesn't have a maxima, but then if we find the critical point, then that must be a minima. Okay, so and we got as we saw, the global minimum value of the function is 0.75. And there is a confusion while I am doing this problem. I first took that 3 by 2. So that means I am taken the critical point or minimum point. That means I am writing the answer as 3 by 2 and I check the answer key. Then I saw that 3 by 4. So that that might be a confused. That means the global minimum value of f of x. It's not asked about global minima point. It's a minimum value. So you should be careful about that also. So the answer will be 0.75. And is it clear, right? Okay. So okay. So now we can move to another ODE question. So this is again a 2-mark question, and this is also an important question because y is 1 to infinity be the solution of the differential equation, and we have given the differential equation as y double dash is equal to y double dash minus 2y divided by 1 minus x square equal to 0, and satisfying these two conditions. Okay, and I have to find out y of 3. And one thing you should remember that this first of all, if you got a ODE problem, you just guess for a solution. That means guess a solution. Okay. So if this equation can be written as y double dash is equal to 2y by 1 minus x all square. And while doing the problem, I think that from where I got 1 minus x square, for what derivative I want 1 minus x square. So by guessing, I just take y equal to 1 by 1 minus x. And then I find out the derivative. So that is minus 1 minus x all square, and minus 1 is 1. And so as I got the solution as 1 by 1 minus x all cube. And this is actually equal to y double dash is equal to y by 1 minus x all square. But then after that, I just check this condition. But this condition doesn't satisfy. So I change this into y equal to 1 by x minus 1. So that is my initial guess. So first of all, you try for a guess for these questions in ODE, because most of the ODE questions will take a lot of time to solve the problem. So if you get a guess, then it will be very useful for the examination. And don't lose time for that. For try it, look. And I got this within 1 minute. I got this solution, and I change. So I take y equal to 1 by x minus 1. At first I got this solution. That means I'm guessing this, but later I changed it to this. And then y dash is equal to minus 1 by x minus 1 all square. Y double dash is equal to 2 by x minus 1 all cube. So y double dash is equal to 2 by x minus 1 all cube. Then that can be written as y double dash is equal to 2y 1 minus x square. And also our solution, we have to cut 1 by x minus 1. So what is y of 2? Y of 2 is 1 by 2 minus 1, that is 1. And y of limit x tends to infinity, 1 by x minus 1, this goes to 0, right? So this satisfies the condition. So I got the answer very quickly. Okay, so that is by method. And also I want to find out the solution, right? Solution y of 3, that is equal to 1 by 3 minus 1, that is 1 by 2. So 1 by 2 is the answer. So I just y of 3 equal to 1 by 2. So now if you try for a guess and you failed, and don't take a lot of time for that. Okay, so if you fail that and you didn't get a guess in 30 seconds or 1 minute, you go for the direct one. So the direct method is something trickier here. So in most of the case, we might have a question on Cauchy-Euler equation. Okay, Cauchy-Euler equation. And there is one more equation called homogeneous Legendre linear equation. So homogeneous Legendre linear equation is of the form a plus bx whole square y double dash b naught a plus bx y dash plus a naught y equal to 0. So this is actually a Legendre equation, and this can be so. So the thing is, we can rewrite this ODE in the form of a Legendre equation, right? So let me write. Okay, so let me write y double dash minus 2y divided by 1 minus x all square is equal to 0. And this is actually equal to 1 minus x all square y double dash minus 2y equal to 0. So this is of the form of a homogeneous Legendre equation, right? Now, there is a method to solve Legendre equation, and you can solve it by using this substitution. A plus bx as a plus bx equal to e raised to z, then z is equal to log a plus bx, and this can be written as by substituting this, we can write like this, and d1 is dy by dz. And I'm not going to solve all this and derive, because this is available in most of the textbook. You should refer this. And also for in JAM examination, on the examination hall, you didn't get this time to substitute and derive this solution. So you should study what is the solution. So this is ODE, homogeneous ODE. This can be rewritten as in this format. Okay, and that means we are substituting a plus bx equal to e raised to z, and z equal to log a plus z. Then this equation can be rewritten as a ODE with the constant coefficient. Okay, constant coefficient. So here this is the constant coefficient. Okay, and d1 is the derivative dy by dz, and you should study this. And in this case, we can rewritten it as b square d1 square y b into b naught minus b d1 y a naught y equal to 0. And once again, I'm telling you that you don't get time to solve these problems directly in the examination, but you should study this type of ODE. Okay, the solution. So this can be easily rewritten as like this. And the characteristic equation will be b square r square plus b naught minus b r a naught equal to 0. And this can be written as y double dash minus 2y divided by 1 minus x square equal to 0. This can be written as in this format, and this is a Cauchy Legendre homogeneous equation. And here actually in the place of b we have minus 1, in the place of a 1, in the place of a naught minus 2, right? B naught is equal to 0. So now you can directly substitute in this characteristic equation, and we will get a characteristic equation. So that is r square minus r minus 2 equal to 0. So the solution of this is r equal to 2 and minus 1. And you can write, okay, I told you that this equation, now we are changed the variable x to z, and the solution is of the form y equal to a e raised to 2z plus b e raised to minus z. Okay, now the solution, now we know that z, okay, z equal to log of 1 minus x, and so we will substitute here, and we will get y equal to a 1 minus x all square plus b 1 minus x. Now we will put the condition y of 2 equal to 1, and y limit extends to infinity, y of x equal to 0. So if I put this condition, okay, y of 2 equal to 1, then I will get a equal to 0 and b equal to minus 1. So then our solution is y equal to minus 1 minus x, 1 minus x, that is y equal to 1 by x minus 1, and the solution is 1 by. So so this is the method to solve the problem, and it takes a lot of time. So that's why I told you that you try for a guess. If it is fine, you can solve it within 1 or 2 minutes. Otherwise, it will take time. Okay, so time consuming problems. ODs are generally time consuming problems. And if anybody have any question regarding to this question? And there may be many other methods, and also, so you should focus on this Legendre, homogeneous Legendre linear ODE, and this is something like Cauchy-Euler ODE, and these are very important type of ODEs. Okay, so the thing is, you should do the problems in stipulated time. That means you should do it in with a minimum time. Then only you can get a good score. Okay. The next question, I'm going to abstract algebra, and this is the number of permutation in S4 that have exactly two cycles in their cycle decomposition is equal to. Okay, so this is one of the easiest question. Okay, the number of permutation in S4, and we know that what is a permutation. A permutation, S4 is actually set of all permutations of 4 letters, right? Okay, now that have exactly 2 cycle decomposition. So, and also we know that S4 is a group of permutations of 4 letters, and there are 2 possible cycle decomposition. That means any permutation. For example, if I'm taking sigma belongs to S4, it's a permutation that can be actually written as 1, 2, 3, 4. An example is 2, 3, 4, 1. So this is actually a permutation, and this permutation is I can written in the cycle format. Okay, you already know these things. 1 goes to 2, 3, 4. So this is one of the method, and this is a cycle, and we know that any permutation can be written as a product of disjoint cycles. Any permutation that can be written as a product of disjoint cycles. So now our question is, in S4 that have exactly 2 cycles in their cycle decomposition. So there are only 2 possibilities. One is of the form 1 cycle and 3 cycle. So this is total 4 letters. And other is of the form this 1, 2, 3, 4. And this is one form 1 cycle and 3 cycle. 3 cycle. That means the length of the order of the cycle is length of the cycle. That is 3 letters are there, and in this cycle 1 cycle. So 1 and 3 is 1 cycle decomposition of a permutation that have 2 cycle decomposition, 1 and 3, or this is a 2 cycle decomposition. Both have 2. Both cycles have 2 letters. And now, in order to calculate this number of possible ways, I can choose this first letter in how many ways? There are total four letters in the permutation, and I can choose choose 3 ways, and also okay, and also this this cycle, this as 2, 3, 4. In how many ways? Sorry, this is 4 choose 4 ways. And how many letters are there? 4 choose 3 ways. And here in this cycle decomposition cycle, 3 letters are there. That means 2, 3, 4. And we can choose it in 3 minus 1 factorial ways. That means the arrangement of 2, 3, 4 in a cycle, it is up to 3 minus 1 factorial. That means if you have n letters can be arranged in n minus 1 factorial ways. So the total possibility is 4 into 2, which is equal to 8. So number of ways this can be written as 8 ways. And now in the second format, we have 1, 2. 1, 2 that can be chosen for choose 2, and here this is 4 choose 1, right? 4 choose 1, not 4 choose 3. It is 4 choose 1, and here 4 choose 2. And also this cycle is 3, 2, and this can be written as 2 minus 1 factorial base. And also we know that 1, 2, 3, 4 is same as 3, 4, 1, 2. Okay, so if it is coming like this, so you have to divide it by 2 factorial. So the total number of possible ways you will get is 6 by 2, that is 3. So the answer is 11. Total 11 cycle decomposition. That means there are exactly 2 cycles in the cycle decomposition. Number of permutation in S4 that have exactly 2 cycles in their cycle decomposition is equal to 11. So if they asked any other instead of S4, if they asked in S5, then how many possibilities of 2 cycles are there? One is 1 and 2, 3, 4, 5. Okay, S5. And other one is 1, 2, 3, 4, 5. Okay, so these are the 2 possibilities, right? Is there any other possibility? So now you have to check how many permutations are there for these 2 possibilities. So for this 5C1 into 4 elements are there. So 3 factorial plus the next one is 2. 5 choose 2 into 3 minus 1 factorial. So this is a total number. So this is very easy question from the abstract algebra area. So we can expect such questions in next JAM 2024 also, and this can be easily done. Okay, any question for this question? Anybody have any doubt? Okay, so let us move to the next question. And this is also JAM 23 2023 question, and this is one more question, and it's very easy question from linear algebra. Okay, so in most of the case, such question will be asked for examination. For example, this is a linear transformation. Let T from P to R to P4R be a linear transformation given by T of P of X equal to P of X square. Then the rank of T is equal to. So if you have a linear transformation, then it's better, it's always you need to change it into the matrix form. So if you a linear transformation, there must have a corresponding matrix. So in order to find the rank of T, you just find the corresponding matrix of T and rank of the corresponding matrix of T. And most of the examination, there will be a question like this. Okay, or from this area. Okay, so how to do this? Now first our step is we have to find the matrix representation of this, and we know that this P2, the linear transformation is completely determined by the basis. So the basis, standard basis of P2R. P2R is actually polynomial of degree less than or equal to 2. And this is polynomial of degree. P4 is polynomial of degree less than or equal to 4. Now the standard basis is P2 is 1 x square. So that is one of the basis. And another basis is for P4 is standard basis 1 x square x cube x raised to 4. So these are the two bases. Now we will determine where this basis T of 1 maps, and we will find the matrix representation. So what is T of 1? T of 1 is T of P of x is actually P of x square. So T of 1 is 1 itself, because here the polynomial is 1. 1 is a constant. So T of 1 is 1. And this can be written as a linear combination of this, right? 1 into 1 plus 0 into x plus 0 into x square plus 0 into x cube plus 0 into x raised to 4. Now, next, T of x. T of x is actually T of P of x instead of x, then it maps to x square. So T of x is x square. That can be written as a linear combination of this 0 into 1, 0 into x, 1 into x square, 0 into x cube, 0 into x raised to 4. And there is one more element, x square. So T of x square is actually T of x square is x square all square, that is x raised to 4, right? So x raised to 4 can be written as 0 into 1 as a linear combination of basis element of P4. Okay. Now the matrix representation is actually, you take the column. Matrix A is, the first column is the coefficient of this. Okay, that is 1, right? 1, 0. The first column is the coefficient of first T of 1. 0, okay, 0, 0. So 1, 0, 0. And second column is 0, 0, 1, and 0, and 0, right? And third column is this 0, 0, 0, 0, and 1. So the matrix representation of T is A. When we got A is the matrix representation of T, then it's very easy to find the rank of T. So what is rank of A? Rank of T is same as rank of A. So anybody tell me what is rank of A?
3.
3. It's very easy. It's 3, right? Okay. It's 3. Rank of A is 3. Therefore, rank of T is 3. And you remember one thing. In most of the question, most of the examination, JAM examination, I saw such questions. So if you have any question related to linear transformation, better you just change it into the matrix format and solve the problem. Then it will be very easy. Okay. So next is again an OD problem. And okay, so while doing this problem, I'm very slow in solving the problems, and that is one of my problem. My personal problem. That means I take a lot of time to calculation, lot of time in calculation. And when I'm doing this problem, one of the problem is this is a direct question. So think about this. This is a direct question, and this OD is y double dash minus 2y dash plus y equal to e raised to x. And y of 0 is 0, y dash of 0 is minus 1 by 2. Then y of 1 equal to dash. So this is a direct second order question. Okay, second order question. Second order homogeneous ODE. Okay, I will share the notes also. Okay, don't worry. Then we can solve this, right? Y double dash minus 2y dash plus y equal to e raised to x, right? Now we know that how to solve. So this is a second order ODE, and we know that the solution y of x is solution of homogeneous equation plus solution of particular integral. And what is homogeneous equation? Y double dash minus 2y dash plus y equal to 0. Now we will find the characteristic equation r square minus 2r plus 1 equal to 0. So the problem is r equal to 1, 1. I think 1, 1. Okay. So r equal to 1, 1. And the solution is y equal to c1 e raised to x plus, this is a double solution, so c2 x e raised to x. Now again, our right hand side is the same as yp is same as the solution, that e raised to x, and also x e raised to x is same. So you cannot take a e raised to x as a solution or ax e raised to x as a solution, but yp you can take a x square e raised to x as a solution. Now the thing is, now you find out yp double dash and then solve the problem, and you will get the value of a. So this is the direct method you always do, and I think it will be very time consuming, right? So instead of that, I'm using here Laplace transform. If you know the Laplace transform very well, we can very easily find the answer. But the thing is, if you want to know the Laplace transform of each function, so if I am doing in this way, it will take a lot of time for me to solve this problem. But when I am using Laplace transform and I'm good in Laplace transform, so I can easily find the answer. So the thing is, I will apply both sides Laplace transform. So this is second order ODE, the constant coefficient, and Laplace transform of this is equal to, okay, so the thing is, if you know the Laplace transform very well, you can use this method. Or I will tell you that at least you study to solve Laplace transform, to solve ODE using Laplace transform. That section, that is very important, and also that will be very helpful to solve the problem. And most of the case, nobody is I never saw anybody doing taking Laplace transform and solve these problems of ODE in competitive level examination, but usually I do by using Laplace transform. And you know that Laplace transform of y dash is actually uh, y double dash is actually s square Laplace transform of y minus s into y of 0 minus y dash of 0. So that is instead of Laplace. So actually this is linear. I can write L of y double dash minus 2 times L of y dash plus L of y equal to L of e raised to x. Right. Now this L of y double dash is can be written as Laplace transform of derivative s square L of y minus s L of y of 0 minus y dash of 0, and also minus 2 y dash can be written as s L of y. So L of y dash is actually, the formula is s L of y minus y of 0, and L of y equal to L of e raised to x. And the important thing is you want to know the Laplace transform variable. So this can be written as s square L of y, and I am applying the limit y of 0 is 0, y of y dash of 0 is minus 1 by 2, and there is plus 1 by 2 minus 2 into s L of y L of y. Now you can take L of I as common, and I'm taking minus 1 by 2 the other side. Now I'm equating this. So this is actually equal to s square minus 2s plus 1 is actually equal to s minus 1 all square, right? And this can be written as 1 by s minus 1 minus 1 by 2 is actually equal to 3 minus s divided by 2 into s minus 1. Now this 3 minus s can be simplified as minus s minus of s minus 1 divided by 2 into s minus 1 plus 2 by 2 s minus 1. Now L of I is actually equal to 3 minus s into 2 s minus all cube, right? This is all cube, and that again rewritten as like this. And now we will take the inverse Laplace transform. So L of I is actually equal to this and this get cancelled. So you will get minus 1 by 2 s minus 1 all square plus 1 by s minus 1 all cube. So now I'm taking inverse Laplace transform. So the inverse Laplace transform of this is actually L of L inverse of minus 1 by 2 s minus 1 all square is actually minus 1 by 2 x e raised to x. And also this is 1 by 2 x square e raised to x. Now it's very easy. I want to find out y of 1, right? Y of 1. Y of 1 is, I'm applying this, y of 1 is 0. So the answer is 0. So the thing is, you can solve ODE by using Laplace transform and also direct method. Both method is somewhat useful because sometimes Laplace transform is very easy to solve in some questions. It may takes a lot of time. This question also takes a little bit time, but if you are confident in Laplace transform, you can try for it. Otherwise, you can quickly do this problem. Okay, so there are many methods to solve a problem. So that's a very important thing. And anybody have any question regarding to this solution? So the thing is, you have to know the Laplace transform very well. Otherwise, it will be very difficult. So if you know Laplace transform, then it is a better method to solve ODE of this scale.
Sir,
Okay, tell me.
sir, in which OD questions we can apply this Laplace transform? Is it
In
applicable everywhere or like
no. The questions like this. That means constant coefficients are there, and also it's you can apply for non-homogeneous linear ODEs. Non-homogeneous linear ODEs with a constant coefficient. Okay.
Sir, are
And
these problems called initial value problems?
yes, initial value problems you can solve by using Laplace transform. Initial value problems, non-homogeneous or homogeneous ODE with a constant coefficient. So sometimes it will be very easier. Okay, in some questions it will be very easy to solve, and it doesn't take much time if you know Laplace transform very well. Otherwise, you try to do the usual conventional method. And one of the thing is the question paper setter will take your time. One thing is they will set the questions in such a way that they will check not only the solving skill but how to manage time. That is one of the important thing, and also how you approach the question. So sometimes in the conventional way, if you are going to solve a problem in conventional way, it will take a lot of time, and it will affect your overall result. But you should focus on in different ways, and try different methods to solve the question. And you just think that if you are a question paper setter for a IIT JAM question, how you will give a question, and that should be in your mind. Then and like that you should approach for each question. Okay.
So how to decide
And
like,
next,
for a particular question, which method we should apply to get the fastest solution?
okay. So that's from only you will learn from the experience. So you try to, if you are getting a question, you try to think about different methods, different type. That means if you are solving a question in one method, and don't move it away while you are preparing for examination. Okay, you should think about different method and different type of answers. And that means if you are solving in the method, you try to solve in another method, and you try to solve some another method for the same question. Then you will learn that, and there is the it will learn only from the experience, right? I think my answer is
Okay, sir.
okay. So let me move to the next question. Okay, so this is also one of the easiest question, and S8 sigma belongs to S8. S8 is a permutation group with 8 letters, and order of sigma denote order of the permutation sigma. And I want to show what is the maximum of order of sigma. Sigma belongs to 8, maximum order. Okay, so what is the maximum of order of sigma where sigma belongs to 8? S8. So we know that order of a permutation is the LCM of order of disjoint cycles of that permutation. That means if you have a sigma belongs to S8, this sigma can be written as product of disjoint cycles, right? So this is cycle 1, cycle 2, cycle 3. Then what will be the order of sigma? This is LCM of order of cycle 1, cycle 2, C2, and cycle 3. Okay. So now what is order of a cycle? Order of the cycle is actually length of the cycle. For example, I have a sigma equal to 1, 2, 3, 4, 6, 7, 8, 4, 6, 7, 8, and 5. Okay, so this is a sigma in S8. Then the order of this is 3, and order of this is 4, and the order of this is 1. So the order of sigma is actually LCM of 3, 4, and 1, that is 2. So that is the method of finding order of a permutation. So here it is asked that what is the maximum order? Okay, so that means if sigma belongs to S8, this sigma can be written as product of disjoint cycle, right? So in how many ways we can write? So there are 4 possibilities. One is first cycle is of cycle of length 1. For example, 1, and other cycle is cycle of length 7. Okay, 8. Okay, 7, 8. So this is a possibility of sigma. And another possibility is 2, 1, 2, and 3, 4, 5, 6, 7, 8. That means 2 and 6. You can write 2 and 6, and also you can split it more ways. And another possibility is 3 and that means a cycle of length 3, 1, 2, 3, and another cycle of length 5, 6, 7, 8. Okay. Similarly, 4 and 4. So now, and also you can split it anyway. That means that doesn't make a difference. That means if you split it, LCM of 3, this disjoint 3 cycles, that doesn't make a difference. So these are the 4 possibilities which we will get the higher LCM value. So in this, the LCM of 1 and 7 is 7. And what about LCM of 2 and 6? It is 6 itself. And LCM of 3 and 5, that is 15. So this is bigger one. LCM of 4 and 4, that is 4 itself. So this possibility has the highest order. So if we have a sigma with the order like 2, 3 cycle and 5 cycle, then the order of that permutation is 15. So there is no other possibility which have greater order. So the answer must be equal to 15. So the important thing is, in order to find the order, you have to split different possibilities of the cycle type, and you check which one has the higher LCM, and that is the maximum order. Okay, so this is one of the easiest question in the last year questions. Okay, let me move to the next problem. Okay, again, one of the okay, so this is one of the challenging question I have faced while solving this problem, and I take a lot of time to solve this problem, definitely, because I didn't get in the first, when I am doing this solving this problem, I didn't get the correct idea at the first look. That is important. You may not get the ideas on the first look. Okay, so and I tried a lot to solve this problem, and the problem is, for G belongs to Z, G bar belongs to Z8, denote the residue class of G modulo 8, and the group Z8 cross is equal to X bar belongs to Z8, 1 less than or equal to X less than or equal to 7, GCD of X and 8 equal to 1 with respect to multiplication modulo 8. The number of group isomorphism from Z8 onto itself is equal to dash. And first of all, the important thing is Z8 cross, this is group of units of 8, right? So there are four elements in this group. So there are 4 elements in this group, and remember that this is a group and there are only 4 elements. Then this is isomorphic to a group of order 4 is either it is isomorphic to Z4, it's a cyclic group, or it is isomorphic to V4, that is Klein 4 group. That is V4 is Klein 4 group, that is isomorphic to Z cross Z2 cross Z2. And you know that V4 and Z4 are the only 2 possibilities of group of order 4. And Z4 is cyclic, V4 is non-cyclic abelian group. That is the smallest non-cyclic abelian group. Excellent. Now we have to check which. Okay, so now the thing is, if I am taking 3 square is equal to 9, and 9 congruent to 1 mod 8, right? 9 congruent to 1 mod 8. That means 3 square equal to identity. That means order of 3 is 2. Similarly, I am taking 5 square. 5 square is 24, and that's also congruent to 1 mod 8. And order of this is also 2. And similarly, 7 square. 7 square is 14, and it's congruent to 1 mod 8. And this is also order is 2. So this Z8 cross is every non-identity element has order 2. So it may not be cyclic because there is no element of order order 4. So this is isomorphic to V4. So this is isomorphic to V4 or Klein 4 group or Z2 cross Z2. Now we have to calculate. Okay, so we know that now we want to calculate number of. So instead of Z8 cross, I'm now taking isomorphism from V4 to V4. So isomorphism from V4 to V4 is actually automorphism, right? Isomorphism to itself is automorphism, and we know that automorphism, set of all automorphism forms a group under composition, right? So to calculate number of automorphism in V4, that is same as number of automorphism in Z8 cross. Now the maximum number of automorphism is 6. Why? The question is maximum number of automorphism from V4 to V4 is 6. Why? Anybody have any answer? That means maximum number of automorphism. Okay, anybody?
Automorphism of V4 is isomorphic with S3. So order of
Okay.
that will be
Okay, that will be 6. That is the answer. But I don't know V4. That means automorphism group of V4 is isomorphic to S3. I don't know. If I don't know this, then what I will do? That's the problem. Because if you know this, it's very easy, right? If you know this, it's very easy. And it's only one more question. The question paper setter. Question paper setter done this question by that method, right? So that's only scheme. If I don't know this, actually I forgot this result and I try to solve this problem. So what will we do if we don't know this? Actually, in V4 there are 4 elements, right? A, B, C. And also, we know that in an homomorphism or isomorphism, E goes to E, right? That means identity element goes to identity element. Now there are A, B, C. Okay. And there are 3 possibilities, A, B, C. That means this A, B, C can map to any of these A, B, C. And how many ways this can be arranged? This can be arranged maximum possible ways is 3 factorial ways, that is 6. So how many functions are there? How many functions are there? There is only 6 functions. So that means there is only 6 maps from V4 to V4 in such a way that we are fixing identity element to identity element. So the maximum number of automorphism must be 6. Now the thing is, we know that, and if you know this factor that somebody told me that if a V4 is isomorphic to automorphism group of V4 is isomorphic to S3, it's enough. You know that order of S3 is 6. If I don't know, then what we will do? I got maximum number of automorphism is 6, right? Now what I will do is, and we know that automorphism group is set of all automorphism forms a group. That means now if I am taking any two automorphism, okay, any two automorphism, and so I'm taking any two automorphism, F1 from V4 to V4 and F2 from V4 to V4. Okay, and I will get 2 automorphism. I think I will give you the hint. I think it will take a lot of time if I am solving this problem. So what we will do is, you can try it out. You take F1 an automorphism from V4 to V4 other than identity, F2 from V4 to V4. And then you find out F1 composition F2 is again an automorphism from V4 to V4. And also F2 composition F1. And again a automorphism from V4 to V4. And if F1 composition F2 is not equal to, if you find F1 composition F2 not equal to F2 composition F1, that means this is not commutative, right? Commutative. Okay, I'm not taking the example I'm doing. I will give you the hint. What you have to do is, you take two automorphism from V4 to V4, and you find out F1 composition F2, F2 composition F1, and check whether both are commutative or not. If it is not commutative, you get two automorphism and they are not commutative, then what you can tell about this? Then F1 composition F2 is not commutative to F2 composition F1. Then we can say that this group is automorphism group of V4 is not abelian. Okay, not abelian. Then what we know that if automorphism group is not abelian, and we have automorphism group of V4 is not abelian, and it has only maximum 6 members. So what is the only possibility of order of automorphism group? The smallest non-abelian group is of order is 6, right? Smallest non-abelian 6. So this must be isomorphic to S3. That means number of elements in automorphism group of V4 is 6. So the answer must be equal to 6 non-abelian. Okay, automorphism 6. That means the thing is, you have to, if you know this fact, that is automorphism group of V4 is S3, then you are done in seconds. If you are not know that, then you should try different methods, and it may be time consuming, but you can still solve these problems. So actually I didn't remember this fact, that is automorphism of V4 is isomorphic to S3, and I take a lot of time to solve this problem. So in the correct time, you have to get the correct hint. That is very important. Okay, so I think is it clear? This question is clear. Okay, so what we done is we just take Z8 cross is actually, we find that it is isomorphic to plane 4 group, and we calculate number of automorphisms in plane 4 group, and it has maximum number of automorphism is 6, because there is only maximum number of function is 6, and therefore automorphism must be less than or equal to 6. And we know that automorphism of, or set of all automorphism on a group is again a group, and we got 2 automorphism, and they are not commutative. Therefore the group of automorphism on V4 is non-abelian. Therefore we can conclude that a non-abelian group of order, the smallest non-abelian group is group of order 6 there, and maximum number of automorphism is 6. Therefore the number of automorphism from V4 to V4 is 6. So that we can conclude. So such questions are trickier, but we can solve in any. Okay, next it's another question. Okay, this is from linear algebra. Let A from A is this matrix 1 1 0 0 1 1 1 1 1 3, and this matrix, and B be 5 cross 5 real matrix such that AB is a 0 matrix. Then maximum possible rank is equal to. Okay, so in order to solve this, you have a result. If you know this result, then it's very easy. So we know that rank of A plus rank of B minus n less than or equal to rank of AB, right? Rank of A plus rank of B minus n less than or equal to rank of AB. The n is number of columns. Now, rank of A is equal to 3. Rank of A is equal to 3. And okay, if you can now rank of A 3, you can solve it by using row. You find row echelon form or this, or if you find the row echelon. I'm not doing that thing. You can easily find rank of A, right? Rank of A equal to 3 if you find the row echelon form. And n is number of columns is 5, and 3 plus rank of B minus 5 less than or equal to rank of AB, and rank of B, so we want to find the maximum possible rank, is always less than or equal to 2. Okay, so if you in an examination hall, you should stop here and you can write 2 as the answer, but this I will get only a upper bound, and we want to find out a matrix which has rank 2 and product of this is 0. So that is important, but in the examination hall, you doesn't go for that. If you get this, you should write this answer and stop and move to the next question. But when after that viewing, if you have time, then you should find whether there exists a matrix B whose rank is 2 and product is 0. So now I'm just showing you that from a rank of A 3 and matrix B, some matrix B using Python. Python programming language is there. Okay, let me go to the okay, Jupyter. So let me move. I will show you that some interesting. I will show you a matrix B such that so this is actually our matrix A, right? And you see this matrix A, and we can use Python programming to find the rank of the matrix. So you can actually, if you run this, you will get rank of A. Rank of A is 3. So this is the matrix 3, and I don't know whether we will. Okay, so we find rank of A. This is same matrix what we have there. Okay. Okay, so now the another matrix B. So this is a B matrix. Okay, so I find out this B matrix. Then I'm finding the product AB equal to NP dot AB. So if you find that product of AB 0, 0, 0. That means A into B, this matrix is 0, 0. And rank of B I got it as 2. So this is an example for a such matrix. Okay. So I will move to okay, I will move to the next. So you can easily find that for when you are in examination hall, you just stop there. Now, if you don't know this, this result, so then what we will do? So you think about another alternative method. So we know that always rank nullity theorem, right? Rank of A plus nullity of A equal to number of columns or n. Now we know that since A of AB equal to 0, we have each column of B belongs to null space of A, right? We know that AB equal to 0, then each column of B belongs to null space of A. So what you can conclude, column space of B is a subspace of null space of A. So what you can conclude, column rank of B equal to, we know that column rank of B is same as rank of B, and this is always less than or equal to nullity of A. Okay, null space of or nullity dimension of null space of A. And also you can substitute in this equation number 1, rank of A plus nullity of A equal to n. So if you substitute this, rank of A we already got 3 plus rank of B, that is less than or equal to 5. So rank of B is less than or equal to 2. So this is actually rank nullity theorem. You can use rank nullity theorem to solve this problem. Okay, so if you don't know that result, you can derive that result from rank nullity theorem. So you try for many methods to solve a problem. And okay, so the 9th question. This is again a simple question in real analysis. Okay, but it also takes a lot of time to solve the problem. So in order to most of the cases, if you have a questions to find the limit and there is an n, then you should look for a recurrence relation. Okay, then that might be easy to solve this problem, right? So I'm taking in equal to just this. This is in. Okay. Now, if I can write x raised to n into n minus 1 into x divided by x plus 1. Okay. So that I can written as x raised to n minus 1 into 1 minus 1 by x plus 1 dx. So that is equal to in equal to 0 to 1 x raised to n minus 1 dx minus x raised to n minus 1 by x plus 1. Okay, x raised to n minus 1 by x plus 1. So now why I am doing this? Because I want to get here. So this is actually n minus 1, right? So I got in equal to something minus n minus 1. So now what I will do is in equal to this x raised to n minus 1 dx into minus in minus 1. Now I'm taking both the other sides and I'm multiplying with the limit. No. Okay. Now so what I am doing is I'm taking in plus in minus 1 equal to integral 0 to 1 x raised to n minus 1 dx. Now I'm taking limit n tends to infinity. In and in is that is you can limit n tends to infinity in, and in minus 1 is actually n. In minus 1 limit n tends to infinity is integral 0 to 1. This is actually 1 by n. Now I'm multiplying n on both sides. So limit n tends to infinity 2n in equal to 1 by n into n. So that is 2 into limit n tends to infinity n into in equal to 1. So limit n tends to infinity n into in is equal to 1 by 2. So the answer is actually limit n tends to infinity n into in is this is equal to 1 by 2. So this is one some more easy problem. You have to do some calculation in this is some +2 level questions, I think, but you have to do the calculation in the right time. Don't take much time to solve these problems, and you will easily get the mark. And one of the main problem in NAT is you will not get, you will don't you cannot understand whether the answer is correct or not. There is no option. Okay, so let us move very fast because
Sir, I have a doubt.
the time is okay. Tell me.
Sir, how you got 1 by n there?
1 by n. Oh, so that is integral 0 to 1 x raised to n minus 1 dx. If you are integrating this, we know that x raised to n. What is integral of x raised to n? This is x raised to n plus 1 by n plus 1. So here x raised to n minus 1 is there. So x raised to n by n, 0 to 1. If you are playing, you will get 1 by n, right? So what is integral of 0 to 1 x raised to n minus 1 dx? Right.
Also, we are applying limit n tends to infinity there, no, sir?
Okay, limit n tends to infinity. Actually, you can find the actually limit is outside, right? If you know, if you can find this limit, okay. If you can this, then if you find this integral and you can apply the limit, but this integral is not easy to find, right? So one method is you can apply limit after finding the integral. Okay. So but here you cannot find that. That's the problem. So if you, one method is if you solve this and find the integral, that's fine, right? Finding integral and then apply the limit. That's we want. So that's why we are here. First find the integral and then apply the limit. Okay. Is it clear?
Sir, when we apply limit on RHS side, won't it become 0, sir? 1 by
Here
n tends to 0, no,
1
sir?
by n into 1 by n into n is there, right?
In the above step, sir.
Here.
On LHS, you have applied limit. On RHS also, we will apply, no, sir?
Okay. Limit n tends to infinity. 1 by n into n. This n and n get cancelled, and after that, there is no n is there, right? Have it clear?
Okay, sir.
So that is limit n tends to infinity 1. So that is 1. Okay. Because here we got 1 by n, right? So I am multiplying n on both sides here. Okay. Here there is n, and I am again multiplying here n. And this n and this n get cancelled. And what I can take 2 outside, right? Limit n tends to infinity n in equal 1. And again, limit n tends to infinity n in equal to 1 by 2. So after I am cancelling out n, then it is n by n, that is 1, right? Okay. Just try it. And another question is W, is it clear, right?
Yes, sir. Yes.
Okay. So now another question is W be a subspace of M3 consisting of all matrices with the property that sum of the entries in each row is 0. So what is the property? Sum of the entries in each row is 0. And also sum of the entries in each column is 0. I want to find out the dimension. So what is M3 of R? M3 of R is set of all 3 by 3 matrices. Each element is a real number. Okay, so if you have 3 by 3 matrix, how many elements are there? 9 elements, and all these elements you can choose any value for this, and you can have the, okay, so that is a 3 by 3 matrix and 9 elements will be. Now what is the dimension of a vector space? Is the number of elements in a basis of the vector space, or simply number of linearly independent vectors that span the vector space. So dimension of M3 is, you can find the basis as 1 0 0 0 0 0 0 0, and similarly 0 1 0 0 0 0 0 0 0, and similarly you can find 0 0 0 0 0 0 0 1. So there are 9 elements, and this will span the M3. So the dimension of M3 is, or I will show you what after solving this. And also, now what is our question? Our question is, I want to find out a 3 by 3 matrix whose row, that means A, B, and its sum must be 0. So this must be actually, if first element A, second element B, third element must be A minus B, right? A minus B. If this is C, this is D, minus C, minus D. And this is minus A, minus C, minus B, minus D. Then this sum is, this is 0. Okay. So this is actually, this is the matrix, and we want to find out the dimension. So similarly, we can find the basis element. How to find the basis element? 1, 0, minus 1, 0, 0, 0, minus 1, 0, 0. Similarly, you can find the second 0, 1, minus 1, 0, 0, 0, 0, minus 1, 0, and so on. So the thing is, you can find the basis element. Okay, basis for this vector space. But I will tell you, this is somewhat time consuming, and basis finding, and it's somewhat time consuming, right? So I'm not doing this problem because we have also very less time. So you can actually find the basis for this subspace of this W, that means W, subspace of this. So I will show you, I will tell you an easy method to solve this problem. So for that, what you have to do is, you have to, in order to find the dimension in a vector space, you have to find out the number of free variables. So first of all, I will show you that. So what is dimension? One quick way to calculate the dimension is to calculate number of free variables. So M3 of R, and we find that the dimension of M3 of R is 9, right? So why it is 9? In a 3 by 3 matrix, the first element, that is a free variable, you can choose any value, A, B, C, D, E, F. Everything is free, and you can choose any value for this. G, I. Okay. So this every values is free. So number of free variables in this matrix is 9. So the dimension is 9. Okay. Now you, if you think this like our subspace. Okay. So what will be the subspace? If I'm taking A and B, these A and B are free variable. Is the third element is free? Because if A and B is there, then this element must be minus a minus b. So this is not free. Okay, this is free variable, this is free variable. So number of free variable is 2, and I can choose any value here, c, d, but this variable is not free, td, minus c minus d. Otherwise this will. So another 2 variable is 2. So number of 2 free variables is a, b, c, d. Now what about this? The column sum must be equal to 0. So this must be minus c. This is not free. You should write this element itself. And this is minus b minus d. This is not free. This is not free. And also the last row must be, last element must be 0. The number of free variables here is 4. So the dimension is 4. So in order to calculate the dimension of a vector space or a vector subspace, in such questions, you just try to identify the number of free variables. So that must be the dimension of a vector subspace. Because if you are finding if you are finding the basis element and then you count the number of elements in the basis, it will be very time consuming. In such question, the easier method is you calculate the free variable. So for example, I will show you one more example. For example, if you have a subspace W1 equal to, okay, so I am writing here. Okay, I'm writing here. If W1 equal to set of all x, y, z belongs to R3, then x plus y equal to 0, and okay, so this is a subspace. Now the thing is, the R3 dimension of R3 is 3. What about the dimension of W1? Anybody tell me? This is W1 subspace such that x, y, z, where x plus y equal to 0. So how many free variables are there?
2.
2, right? Because
Yes, sir.
you can choose x and z free. Y is depending on, y is always minus x. So in order to calculate the dimension, you just calculate the number of free variables. Have you got it? Okay. So there are many questions. I think we already reached the time. I may share these notes to you because there are 5 more questions I have prepared. While I am explaining, we have to put, that means we have to approach question in different manner. So that's why I'm taking a lot of time for solving this problem, because it's very important to approach each question in different methods. Okay, so I will definitely share this slide, and right now I think time is up. I just will stop.
Okay, dear friends, now it is the time for sharing your queries or feedback. You can ask if you have any doubt. Otherwise, you can share the feedback of the session.
Good evening, sir. My name is Lakshmi. I am currently in my final year of Mathematics Honours from Hansraj College, University of Delhi. I don't have any queries. I just wanted to let you know that it was a very helpful session, especially in this last 10 days. You know, when I was actually able to solve the question, it was a great confidence boost because the nerves are here. The exam is very near. So thank you so much for taking out the time. Thank you so much.
Thank you, Lakshmi.
Thank you.
Yeah, so this session was very amazing. Like we have revised so much concept of so many topics like group theory and some results in linear algebra. And also in OD, I never applied like Laplace transformation. I did first time. So we can save time in upcoming exams like GATE and JAM. And so this session was very helpful for the exam. And And sir, I am MSc first year student from ICT. And thank you, sir.
Thank you, Sneha.
Good evening, sir, and good evening, sir. Asif, sir. Today I got to know about ODE and other problems, and it was the Laplace transform that applied those we are studying in our fourth semester, so it was kind of more challenging for us. Still, you helped us to solve these questions. And thank you, Vinod sir, thank you, Asif sir. Have a good night.
Thank you,
Okay,
remarkable.
thank you.
Yes.
I am Dharmendra Singh from Kasganj, UP. This class was very nice. I want to ask some tips about what should we keep in mind.
The thing, what kind of it's the thing is we will use different techniques while writing the examination or for preparing the examination. If you have 3 months for preparation, you should plan likewise, right? For the first month, you should go through the topics and do more problems and more concept. And one thing is you have to download the question papers and do problems in this question paper and identify the areas, syllabus or areas where these questions are coming. And then in the second phase, you have to solve every possible question papers. And then third phase, if you are preparing for 3 months, the last month you should write exam, practice exam. That's very important. You should take the question paper and set the time for, if it is 3-hour exam, you should just go for 2.5 hours and do maximum number of examinations. Setting up, then it will be very useful. And also, if in the exam hall, you should think, if the exam is on February 11th, I think. So in the examination hall, you should remember one thing: this exam is for to recruit students to the one of the prestigious institute. So the questions must be you should accept that standard. So in each question, there may be a clue to solve the question, and it may not be direct. Some questions are direct, but there may be some clues. So you should identify the question, and most of the times you doesn't want to use the conventional method. You try for another easier method or another tricky method, and this will learn only from the experience. I think my answer is clear, right?
Okay, thank you. Thank you, Dharmendra. Yeah. Yes, others. Anuvind?
Hi, sir.
Good
Hi, sir.
evening,
My name is Sahita.
Yeah.
I'm a student of BSc Mathematics second year of St. Paul's College, Kalmasheri. Today's sections made me a lot of things to understand, except the Laplace. All the other topics was new for me since I was a Corona batch student. For me, for myself, I think I can crack the next jam because by following this was my first sections and it's helped a lot to me to maintain myself a self-confident. Since I was a Corona batch, I was afraid that is MSc, I can capable for the MSc. So in the BSc, my own class, Ramagan was my colleague. When he says about something, I was like, nothing. I can't respond to the questions or the topics teachers ask. So now onwards, I can. I want to study a lot of things, and the sections help me to motivate myself. And so, if you don't mind, can you give my tips for understanding the modulo concept?
Okay. Shahina, it's very important to solve the problems. You can learn the mathematical concept only by solving the problems. I think for abstract algebra part, you have to remember a lot of theorems and all to solve the problem. But if you are doing such GATE and NET and other entrance level examination problems, by yourself and you are practicing that, then definitely you will understand the concept. The only way to study, for my point of view, is by solving the problems. It's very important. If you are solving the problem, the good problems, exercise problems, then it's very easy to understand the concept. Otherwise, you will forget everything you have studied in your classroom. No, it's only by practicing the problem you will understand the concept. I think good.
Thank you.
So do more problems.
Thank you, Sahina. And I'm sure that as you are a second year student, certainly in the next year, you will be able to crack this exam if you maintain this enthusiasm throughout. And you can take the advice of Asif to do maximum questions and practice problems. That's the only way to success in any competitive examination in mathematics. Okay, others.
Anuvin,
Yeah.
Sir, I don't know if you
Okay,
remember
okay,
me. I'm Animsi from Govt Brunna College.
yes, I remember you. That's why I called you, because he is a student from Brennan College, and I took IIT JAM class for him in December 14 or something.
Yes,
So
sir.
I definitely. Okay.
Yes,
Tell me.
you discussed some 12 questions from there also.
Yes, yes.
And today's session was very wonderful, and your tips and tricks are very useful for the upcoming JAM exam. We are highly motivated to use such tips and tricks. And thank you, sir.
Okay, thank you, Anuvin.
Okay, Anuvin. Actually, me and Anuvin traveled 2 days together to our. He's from my hometown. So when I taken a session in Brennan College, we both days we travel together. So I remember you, Anuvin. Okay.
Thank you, sir. Thank you.
Okay, thank you.
Yes, others. Yeah, Shikha.
Good evening, sir. I'm Shikha. I'm from
Good evening.
Jharkhand, and I've completed my integrated M.Sc from Birla Institute of Technology, Mishra. And currently, I'm preparing for GATE exam. So your session was really nice. It was full of tricks, tips, which would really help us in our coming exams. So I have one query. Like there is a Laplace equation in ODE. So is there any link between Laplace equation and the Laplace transform method that you introduced today?
It's actually Laplace. In order to solve ODE, this is a trivial method. You can use Laplace. It's not done with Laplace equation. It's just applying the Laplace transform to the ODE. It's a basic thing. I think you might have studied in your degree. Okay. It's only for solving the homogeneous or non-homogeneous ODE with the constant coefficient, and which have initial value problem. So I think there is nothing doing with the other Laplace equation as far as I know. Okay.
Okay, sir. Okay. Thank you, sir.
Yeah.
Thank you, Vinod, sir.
Thank you, Shikha. Yes, others.
Hi, sir.
Yeah.
Hi.
Hi.
My name is Asif Navas, and I'm currently doing my graduation in BSc Mathematics from Government Arts and Science College, Calicut. So the session was really nice, and it really helped us to revise the concepts in this final step. So thank you so much, sir.
Okay, thank you.
Thank you, Abhishna. Yeah, Drishya.
So I am Drishya, BSc second year student from Kerala, St. Thomas College. Actually, I'm preparing for IIT exam 2025, so I have more time to practice more questions, and I am sure that I will crack
Good.
it on.
Okay,
So if you're if you're preparing, that means you have this much enthusiasm for the examination, and you are still a first year student, you definitely crack it. Okay, yes, sir. All the best.
Maintaining the same enthusiasm throughout, that is the main.
Enthusiasm is very important. Consistency is the key for any
Yeah.
success. So be consistent.
Okay, any others? If any of you would like to make a comment, yeah, you can do.
Hello,
Yeah,
sir.
Lish.
I am
Yeah.
Lakshmi. I am from
Yes.
TMC College, Tirur. Thank you so much, sir, for this wonderful session. It was really helpful and informative, and you explained each and every question very clearly. And thank you so much, sir, for spending your valuable time with us. And thank you, Vinod, sir, for organizing such sessions. Thank you.
So once again, thank you, Asif, for being with Math Aspirants. And
Okay, thank you, sir.